Hello. All right. So here I have open the demo project. There is no code in it, so this is exactly what you should be able to download. This one's fairly easy. You could probably make it up on your own, but later on, the kind of boilerplate project stuff, if you will, is going to be more complex. So I figured I would give you that, and that way we could focus just on the code. So what we're going to talk about today is coroutines. I have this little object here with a script. And I'm going to open up this script here, which is actually already open, so it's right here. And it's just a basic mono behavior. We're not going to get into networking yet. But the coroutines are going to be very important for networking for several reasons. And basically, it's going to be important because we want to stop using the update as much. Now, we still have to use it a little bit, but we actually don't need to use update as much as we do. And we'll talk about why that is, and even on single player games, you don't really need to use update. The only difference is on single player games, there's usually the updates are pretty lean, and the only one that's really complex is usually the player object, so it's not as bad. And CPU cycles are pretty cheap nowadays. This will change in a networking environment. So what is a coroutine? So a coroutine is going to be a function, and the return type is going to be IE numerator. We'll call it demo. And automatically we have a problem. So here, demo there's a syntax error, and it's expecting a return of an IE numerator. What the hell is an IE numerator? Essentially what it means is you're going to surrender control. So we're going to do some code. We're going to surrender or return temporarily until a condition is met. And then we will resume code here. Yes. Now, once we reach the end of the coroutine will simply end like any other function. So that we don't have to worry about that. Now, how do we surrender? Well, surrendering code, there's several things we can do, but it's going to start with yield. The syntax is a little bit strange, but once you've got it down, it's fairly easy to memorize. Return new, and then we're going to have several options we can do. We can do wait for end of frame, wait for fixed update, wait for seconds real time, wait until, and wait while. These are conditions we can wait, and basically this is going to be a stall. It's not going to stall the execution. It's just going to disable this function for a certain amount of time, and then it will resume. So we'll say wait for seconds, and we're going to wait for, let's do 3 seconds. 5 is a little bit excessive. So it's going to do some code, wait for 3 seconds, and then do some more code. While it's waiting, it will let other things run. It's not going to just stall the code here and not let anything else run. So this is essentially kind of mimicking what a true thread.sleep would do if you're using, like, say, Python. So here we're going to say debug.log hello, and down here we're going to do debug.log world. Okay. Now, there's one other catch. I have to start this coroutine. And when I start the coroutine, I have to do it in a special way. My preferred method is to do start coroutine, and then we're going to say the name of the coroutine, and then if there's no parameters, I can use this syntax. So once I do this, this will start the coroutine, this will execute. Once I start the coroutine, this will also act as a thread, so to speak. So execution will continue here. In fact, I'll prove it to you. Debug.log inside start. And yes, this is going to be a race condition between debugging this and debugging this. If I remember correctly, the hello will win, but we'll find out. So I'm going to save this. Then I'm going to go back to my Unity. Uh-oh, what's going on here? Come on. I have a syntax. Why is my Unity not behaving? There we go. Okay, and I'm going to run it. We run it. Inside start. So hello did win. Inside start, and then 3 seconds later, world popped up. For those of you who could not see that, let's try that again with not maximize screen. So we'll stop that. Game, we do not maximize on play. Console, clear. Okay, there, let's try this now. So it runs hello, inside start almost immediately, and then world 3 seconds later. So it acts as a timer and kind of gives you a thread ability. That's pretty neat. So what else can we use it for? Well, there's a couple things we could do. Remember that code we used to create a bullet. We'd have like a shoot time, Boolean can shoot equals true, and then shoot timer equals, or shoot timer equals like 1. And then we'd have, this would be a timer that we'd have to cast down in update continuously, F. And when it was less than or equal to 0, we set can shoot back to true. Okay, so let's make a coroutine for this. Now I'm going to use update here, but you'll see later on that we're going to use a different update. So we'll say if input.raw, or get access, sorry, access raw, fire, I forgot to fire, we'll do jump is greater than 0, and can shoot. Then we'll say debug.log shooting. Now, what we'd have to do normally is to, right here, we'd have to have an if statement. If cannot shoot, then subtract time from timer or shoot timer, etc., etc., etc. But we can do better than that. So I'm going to make this 5 seconds actually, because that's a little more a little easier to see. So I'm shooting. So what we're going to do is we're going to make another coroutine. We'll say can shoot is equal to false, because once I call this, it means we can't shoot. I'm going to yield return new wait for seconds, and it will say shoot timer. No, it's not going to. What's wrong? Oops, I reused the name, didn't I? Okay. Shoot timer reset. That's why we don't mess up our names. Okay. Then after that time is waited, we'll say can shoot is equal to true. That's actually a lot easier than trying to do the routine, and it cuts off all the cycles of having to check to see if you can't shoot, subtracting time, and checking to make sure the time is still greater than 0. So here, all I have to do is do a start coroutine. And we're going to say shoot timer reset. And now let's see what happens when I run this. A word of warning though before that. When you start coroutines, I would suggest you think of them as threads. So you do not want to start these uncontrollably. If I had this line outside of the if statement, every frame would start this coroutine, and I'd end up crushing the processor. Because in the end, these coroutines are going to be kind of using a thread to do the underlying work, I believe. So you want to make sure that you only start a coroutine when you need it, and you're not starting a coroutine every update or every other update. It has to be whenever you need it. So this is only going to execute when can shoot is true. So we'll go ahead and save this. And actually, to be honest, I should put can shoot is false down here just to be on the safe side. So there's no possible race condition. I think the other one would have worked, but we'll just do it that way. This is a better code. So can shoots false. So it cannot go back into this. It calls the coroutine, waits for shoot timer, then sets it to true. So we'll run it. Inside start, 3 seconds later, world. Okay, so I hit jump, shooting, okay, good. I can't shoot. Okay, now I shot again. See, let me not do collapse. So we'll count for, how many, say 5 seconds? 1, 2, 3, 4, 5, 6. Okay, so it's a little bit off of my count, but there you see it shoots again. So here I can only shoot every 5 seconds, or I only can print shooting every 5 seconds. So this is a handy way of doing a timer and reducing the CPU cycle here. I will give a warning though that you don't want to overuse this. So if you have for some reason 10 or 20 timers, if they're all going off or they could go all off on the same time, you may not want to do this because then you're going to be dropping 20 threads onto your system, and that's not going to be healthy. But for 1 or 2 timers per script, that should be fine. Again, you can play around with what's good and what's not. But this is an option we can use our timers for, or IE enumerators or coroutines for. So that's nice. What else can we do? Well, one thing we can do is we can actually use our coroutines as a wait. So here, after I print world, I'm going to say yield return new shoot timer reset, which doesn't really make any sense logically. Hold on. New. Sorry. Wait. Not that way. Wait for. Where is it? Okay, so I've just drawn a blank here. I know it's right in front of me. But there is a way to wait for your time. I can start the coroutine. But this will not wait for it. It will wait. It will not end this coroutine until this one's finished, but it will not. It will execute this directly afterwards. So here we'll do debug dot log world. And we'll come back here. So I should see the exclamation mark appear immediately, and then I should be able to shoot again. So shooting, hello world, exclamation mark, and then shooting because it was already running the reset the shoot timer. So this is something I can do. This is not actually waiting for the coroutine to finish. Hold on a second while. Okay. So I was being very silly. I apologize for that. We have this. So if I want to wait for this, I'm going to have to do, and you're going to the start coroutine, but I'm going to have to say yield return new start coroutine. Not new. Just return start coroutine. In this case, it will not print the exclamation mark until it's allowed me to shoot again. So we'll save it and run it. So here it's shooting and then world. And then after 5 seconds, I have the exclamation mark. So in this case, when I do wait for yield return start coroutine, then in this case, I am going to wait for this coroutine to return. So I can now wait for my own coroutines, which is pretty neat. And we'll employ this method on occasion during our class. Okay, so those are kind of the neat things. One other thing I thought I would show you, which is interesting, is we can do a yield return wait until or wait while. So wait while is going to wait while it's true. Wait until is going to wait until it's true. So this is kind of the inverse of each. So basically we're going to do wait until. And the way we want to do this to make our life easier is we can use kind of some strange notation here, but we'll have a constructor, and we're going to cast the Boolean check to this constructor. So we'll have the can shoot equal, let's say, true, and I'll shoot right away, so it'll be false. So here, now I'm going to wait until this variable is true. A lot of times you'll see people doing this on the internet. While can shoot equal false, yield return new wait for seconds 0.1f or something, and they'll be doing this. And so while it's false, they're going to wait for 0.1 seconds. This is fine if I need to do something. However, if I only just want to wait for this variable to be true or false, or wait for this variable to true, I can use this notation and not have this while loop. So food for thought, this will make your life a little bit easier. Both of these are common methods. We'll see we'll actually use this method as well, because we can use this method to find objects while we're waiting for objects to be instantiated. So now if I run this, let's say debug.log, can shoot is true. All right. Oh, come on now. There we go. So run this. So I'll shoot some shooting. World. Wait 5 seconds. Shooting. The exclamation mark, and then shooting, and then can shoot is true, because when I ran the exclamation mark, it reset it. So that's what happened here. But this was essentially waiting for can shoot to be true. Let me reverse it now. We wait while this expression, which is, I could just say wait while can shoot, but we'll keep it that way for explanation. Now this time I'm not going to actually touch anything, so it will be true. Hello inside start, we wait 3 seconds, world, wait 5 seconds, exclamation mark, and now notice nothing happens. I can wait, I'll be waiting here till the cows come home. So nothing's happening, it's not printing, it's true. And I guess I should have changed my debug message, but if I print it, it says shooting and can shoot is true. Actually, can shoot's false in this case. But that's what happened here. This stayed looping or waiting, not looping, but stayed stalled and let other things run until this was no longer true. So that's the difference between wait while and wait until. All right, so that's basic coroutines. I'm going to kind of try to combine this because I feel like it's easy enough. The other usage for the coroutine, and I'm sure there's other ways you could do this, but it's something I find useful because it's built in and I don't have to worry about thread logic or too much thread logic, is notice here the update works every frame. Most gaming computers are going to be running somewhere between 60 to 120 frames a second. Now, question. Do you really need to check the input every time, or 120 times a second? If you do, if you really do, then yes, you're going to use update. But most networking games run on a 10 hertz clock, which means 10 times a second they update the game state, which means at best you're going to be able to move your character 10 times in 1 second. Which means all this logic of checking your input and stuff is kind of wasted. Even on a single player game, it's unlikely that you need that kind of responsive time. So the update is really expensive to put stuff in. I don't know how many people have ever done advanced AI programming, but if you say you have a triple for loop and you have a print statement in the middle of the triple for loop, it will slow your program down immensely. Just because printing out text is more time consuming than doing calculations. So we want to reduce this and keep it as lean as possible. So what I find useful and what I like to do, I'm going to remove this now, or don't, I'm not going to remove it. I'm going to keep this here, is I will do something what I call a slow update. And I can't spell numerator, so it's not going to work. But if I could, okay, good. And I'm basically going to do something kind of, or could be kind of strange if you've never seen logic or thread logic. While true is basically going to be an infinite loop. So this is never going to end. But inside this loop, I'm going to say return, or yield, return new, wait for seconds. I will say 0.05 f, which means it's going to wait for 50 milliseconds and then rerun it. This is going to reduce the number of times I run. But I can now use this as my update, which will be significantly slower than my update and be more efficient, say, for checking input. So here, instead of doing demo, we can do inside start. We'll also do start coroutine, and we'll coroutine, and we'll say slow update. The reason this is really useful for networking is you have the potential to be sending a packet every time you do an input. You may not, depending how we do optimization, but you have the potential to. Therefore, every time you change the input down here, you could be sending up to 120 packets a second. Here, I'm going to be sending 20, I believe. I don't know why I can't do math right now, but 50, yeah, 20. I'll be sending 20 packets a second, which is still not great, but it's better than 120. So here we'll do input, or if input dot get axes raw, say jump greater than 0, and can shoot debug.log shooting, and then we can start coroutine shoot timer reset. Oh, and also we have to say can shoot is equal to false. Again, very important, just like update, I don't want this code here to be running every time I do my slow update either, because then I'm going to be spawning one thread after another inside my slow update, which is just going to kill my system. But now I'm only checking it 20 times a second to see if I need to shoot versus 60 to 120, and everything else should work just as it has before. So I'm going to take this out because I don't want to wait for this anymore. Yeah, so just get rid of this part. I'll just comment it out. Again, if I'm going too fast, please pause the video. So save that. And now I will stop this. I will rerun it. And so start hello inside start, 3 seconds. World, so shoot. I can't shoot for 5 seconds. And then 5 seconds later, I'm going to shoot. Notice you really can't tell that I'm only pulling the input 20 times instead of 120. There really doesn't feel like there's any difference in the responsiveness. I just have to wait 5 seconds. So that being said, I've now reduced the CPU cycle, and again, if I was sending a packet every time I fired, if I was sending a packet over the network, then I've just reduced my amount of network traffic significantly without really risking the quality of my game. Should your game be really a strange game where you need 60 hertz input, and I have to struggle to figure out what kind of game that would be, then you will have to do it inside update. Or but more than likely this will be a much better adequate, or a more adequate solution. That'll be less CPU intensive and less network traffic when we get into networking. So this is it for the coroutines. I'm going to try to post some exercises. Please go back to the video if you missed anything. The important things is how to write a coroutine, how to edit, or how to wait inside the coroutine, waiting on our own coroutines, using a coroutine as a timer, and then using the coroutine as a thread. The one trick with this is you do not want to spawn a bunch of slow updates. So if for some reason I put the slow update in my update function, for some reason I spawn multiple of these, it would actually lag my system out. So if I'm going to treat the coroutine like a thread and have an infinite loop, then I do not want to spawn a bunch of these. Anyway, on next video we will get into networking. Thank you.